Hello viewers, in this video I would like to discuss root of an algebraic expression with the help of Regula Falsi method. So we see that fx is equal to 3x plus sin x minus e to the power x. This is the given expression and we have to find out root of this expression. So we need to find out one interval in which root will lie. So we start with x is equal to 0.3, and when we substitute value of x as 0.3 in the given expression, that is 3 into 0.3 plus sine 0.3 minus e to the power 0.3, we get the value minus 0.154, which is negative. And another end of the interval we may try 0.4. Here we see the value comes positive 0.0975. You may take 0.35 also and check what is the value. Other points in between you may take and check. But once we get one positive and one negative, we are sure that one root lies in the interval. Now we apply Regula Falsi method to calculate the next approximated root. This is the formula. Here x2 is the next approximated root and x0 is 0.3, x1 is 0.4, and function values we have calculated. So fx0 is minus 0.154 and fx1 is 0.4. Now we substitute all these values in the expression and calculate with the help of calculator. So we see it gets 0.3612. So this is the new approximated root, and at this we calculate function value. When we substitute x is equal to 0.3612, we get the value of the function, which comes 0.0019, which is positive. It means 0.4 will be replaced by 0.3612. So now our interval will be 0.3 and 0.3612. Now we calculate next approximated root with the help of Regula Falsi method, and this is the formula. Here we see that x0 is same, but x2 has been replaced by x1. So here x2 value is 0.3612 and x0 is same value, that is 0.3. We calculate after substituting all the values into it, and after calculation we see value is 0.3604. So at this we calculate function value, and when we substitute x is equal to 0.3604, the value comes minus 0.00005, which is negative. So root lies between 0.3604 and 0.3612. It means now our interval is quite small, but we apply the formula again and calculate the value. Now x0 has been replaced by x3. So instead of x0 we write here x3, and x2 is same. Now we have taken all the values here and we substitute values of x3 and x2 and fx2 fx3 and calculate. We get the value 0.36042. so now interval is quite small, 0.3604 and 0.36042. we see it is same up to 4 decimal places, so we may stop here. But if we need more accuracy, then we have to do more calculation. For next iteration we will use 0.3604 and 0.36042 as an interval. So we got our answer correct up to 4 decimal places. Next example is based on transcendental functions, and it is find the root of the equation 10x plus 10 hyperbolic x is equal to 0, which lies in the interval 1.6 and 3. Correct to 4 significant digits using the method of false position. So here we will use hit and trial method and find the interval in which root lies. Here interval is given to x 1.6 and 3, so we will reduce this interval by taking some point in between. We take f 2.35, it gives us value minus 0.03, so function's value is negative here. We take another point 2.37 and we see that function's value is positive. By hit and trial we may try for 3-4 points. If we may get both of them are negative, then we have to take another point. But as soon as we get 2 points where function changes its sign, we can start doing our calculation. So we got one interval here which is quite smaller than the given interval. Given interval was 1.6 and 3, and this new one is 2.35 and 2.37. So we now apply Regula-Falsi method, and this is the formula for Regula-Falsi. We substitute value of x0 as 2.35, x1 is 2.37, and fx1 is 0.009, and fx0 is minus 0.03. We substitute all these values and calculate the value of x2. It comes negative value, which is quite a small value. So we know that next root is between 2.37 and 2.365, because on 2.37 function value was positive, so we have replaced the value where function value was negative. Now we again use regular Falsi method and apply the formula. Replacing x0 by x2, we do all these calculations, and we see the value comes 2.365, which is same as it was earlier. So our result is correct up to 4 significant digits. Thank you.